100 years ago, these lands witnessed an industrial revolution that everyone said was the future. The mines in Gipuzkoa, which are today being spruced up for tourists, fueled the steel industry, which in turn led to an unprecedented economic development that extended to other industrial sectors, from shipbuilding to textiles or heavy machinery. It was the Iron Muscle Revolution. 100 years later, the muscle has given way to knowledge, and iron has lost ground to new materials, such as steel and state-of-the-art concrete with chemical formulae and specific properties that take months to develop in a laboratory. Today, this is the future. The fourth industrial revolution is called 4.0 and is energy efficient with extremely flexible production which anticipates the market through environmental awareness and smart technology. Whilst the future and the force of gravity do not change, the world's most advanced factories will continue to be built from the ground up. One that is increasingly more technological and forms part of the production values of companies. For this reason, we have built the flooring that the fourth industrial revolution requires. To get there, the ProSistemas Innovation Department devoted a year to designing the composition of each of the layers of the flooring, with different resistance properties, color, anti-adherence, and planimetry. During this time, models were built to the scale of the flooring and different elements of the concrete reinforcement to experiment with the most resistant model. A reinforcement model with dual strengthening that in addition would have to withstand one of the most difficult flooring tests, a wearing course without any retraction joints. It was necessary to redesign the conventional geometry of concreting. Understanding and taming the changes in volume of the concrete in the days after concreting is a complex task. It is an autonomous creature that moves forwards and backwards with slight changes in humidity, and as there is a lack of retraction joints, it threatens to explode and break up before the final curing. For example, we know that the fine rain which fell in the afternoon of the 15th of September altered the humidity levels of the aggregates which were to occupy the H3B concreting cloth. This led to some critical delaminations for the concrete, which were resolved in time with epoxy resin injections and cementitious mortar sealing. For this futuristic project, a model of manholes hidden in the flooring was designed, covering the underground supply of electricity, data, and pressurized air. These 144 strategically distributed energy points keep the flooring clear and avoid the inconvenient overhead cables that are found in most factories. The Irizar flooring was already resistant, joint-free, and in a white color that was difficult to obtain. And it was in high planimetry for efficient transit on modern air cushions. However, it also had to be operational for everyday use. It had to withstand the spillage of liquids, such as primers, resins, or paint, as if it were an enormous Teflon frying pan, repelling all products. This anti-adherent property, reducing the porosity of the flooring to the minimum, was obtained by applying a special hardener. We created exact replicas of the flooring, which were subjected to the toughest tests. In the future, the flooring of all factories will be like this. But for now, the future must be stepped on here.